In this session, we are going to talk about binary logistic regression analysis, what it is, how to run, and how to interpret the results. Now, the concept of binary logistic regression. Regression technique is used to assess the strength of relationship between one dependent and independent variables. It helps in predicting the value of a dependent variable from one or more independent variables. Now, regression analysis helps in predicting how much variance is being accounted in a single response, that is your dependent variable, by one or more independent variables. Now, linear regression analysis requires the outcome criterion to be measured as a continuous variable. However, a researcher might find himself or herself in a situation where the outcome is dichotomous or binary. Now, what to do in such a situation? A scholar can use binary logistic regression to assess the impact of one or more predictor variables on the outcomes. In this case, the outcome is dichotomous. Logistic regression analysis is a method to determine the reason and result relationship of independent variables or variable with the dependent variable. So what happens is the logistic regression is actually predicting a group membership, whether based on a certain independent variables, a respondent will fall in a certain group. Since logistic regression calculates the probability of success over the probability of failure, whether you will fall in one or the other group, the results of the analysis are in the form of odds ratio, that is your probability to fall in one or the other group. Logistic regression determines the impact of multiple independent variables presented simultaneously to predict membership of one or other of the two dependent variable categories. In logistic regression, the expected outcome is represented by 1 while the other is coded as 0. Now, based on the values in the independent variable, what happens is you expect the outcome to be 1 or 0. Now, the preferred outcome here is represented by 1. For example, let's say a particular person will only be admitted or admission will be granted in a university to a student based on his good marks in the previous exam, his maybe job experience if it's a master's or PhD degree, or his previous school, certain variables like that. If the student is scoring low on these independent variables, the reason which we call, then he will be or he will not be admitted. Now, there are a few example scenarios that we can look into. So a scholar may utilize binary logistic regression in the following situation. A store would like to assess factors that lead to return or no return of customer. So this is your expectation, return. While no return, you do not expect your customers not to return actually. So your return will be represented by 1, your no return will be represented by 0. A college would like to assess admit or do not admit of a student based on age, grade, aptitude test results. A scholar would like to assess if a particular candidate wins or loses an election based on the time spent in the constituency, previously elected, number of issues resolved. So, win is represented by 1, loss is represented by 0, and if he has spent time, if he's previously elected, and if the issues resolved are in a good amount, then obviously he may win or she may win the election. An HR researcher would like to ascertain how factors like experience, years of education, previous salary, university ranking affect the selection of candidate in a job interview. So selection represented by 1, no selection represented by 0. Now for the case or for this particular session, I've taken this example. So a scholar would like to predict the choice of bank, whether we choose public or private bank, based on independent variables that include technology provided by the bank, the interest rates, the value-added services, perceived risks, reputation, and others. In this case, I've represented the preferred choice by 1 for private banks, or private bank is represented by 1, whereas public is represented by 0. Now, what are the assumptions for binary logistic regression? So, logistic regression does not assume a linear relationship between the dependent and independent variables, because your dependent variable is now dichotomous, it's not continuous. The independent variables need not to be interval nor normally distributed. They do not require a linear relationship nor of equal variance within each group. The error term, residuals, do not need to be normally distributed. The dependent variable, it should be dichotomous with 2 categories. The categories, that is your groups, as dependent variable must be mutually exclusive and exhaustive. A case can only be in one group, and every case must be a member of one of the groups. For example, you can either choose public sector bank or you can either choose private sector bank. So larger samples are needed than for linear regression. A minimum of 50 cases per predictor is recommended by field. Or LeBlanc and Fitzgerald in 2000 suggested a minimum of 30 observations per independent variable. Now, how do you run binary logistic regression in SPSS? So here is my sample data. Here is my dependent dichotomous variable, where 1 is, or the choice 1 is representing private sector bank. This is public sector bank, private, public, and these are my independent variables. So what we do is we go to Analyze, Regression, Binary Logistic. So once we select, we are presented with this dialog box. Our dependent variable, what is your preferred choice of bank? So our independent variables are these variables measured on a Likert scale. So you put them in here. So if you've got any categorical variables, you can click here and move your categorical variables here. But for the sake of this video, in order to keep things simple, I haven't included any categorical variable. So we go to Options and Hosmer-Lemeshow goodness of fit. Select this checkbox and confidence interval for the odds ratio. And this actually represents your odd ratio. Press Continue, press OK. Now here are your results. Your case processing summary, your beginning block, your block 1, and all the results. Now how do we interpret this? In order to have a better understanding of the results, what I've done is I have put them in PowerPoint and I'm going to explain it step by step. Now this is how you run. Just go to Analyze, Regression, Binary Logistic, and you are presented with this dialog box. Just add these variables, select the relevant options from this options box, or rather options button, and you are presented with this box. Now we are going to look into the output. The first thing that you see is your case processing summary. Now what are the number of cases? 341 is the number of cases. In this case, 341 respondents. Next is your dependent variable encoding. In this case, the public sector, or those who choose public sector banks, are represented by 0, whereas those who choose private sector banks are represented by 1. So the dependent variable encoding table shows the coding of the criterion variable, the dichotomous variable. In this case, those who will choose private sector banks are classified as 1, while those who will not choose private sector banks, or rather choose public sector banks, are classified as 0. So in this case, the preferred choice is 1. We want to see what are the factors that would affect the choice of private sector banks. Next is your block 0. Now this is your block 0 without the variables. Now the next section of the output, this is block 0, is the result of the analysis without any of our independent variables used in the model. Now this will serve as a baseline later for comparing the model with our predictor variables when they are included in the analysis. So this is something that offers us a certain kind of benchmark to which we can compare our results and the model fit. In general, the block is not actually usable as there are no predictors in the model. Now, goodness of fit statistics, it helps us determine whether the model adequately describes the data in hand. So what you have prescribed or what you have proposed as a model, does it describe the data adequately or not? So what we have got is, when we go to block 1, we have got omnibus test of model coefficients. Now here we see that the results are significant. So this test is used to test the model fit. Now if the model is significant, which is in this case, this shows that there is a significant improvement in fit as compared to the null model in which there were no variables. So when you add the variables, what happens is you are describing the data pretty well, or your model is actually describing the data pretty well. So you have a good model fit. There is another test, Hosmer and Leemshow test. Now this was to be significant. If you wanted a good fit, you required the omnibus tests to be significant. But in this case, the test has to be insignificant. The Hosmer and Leemshow test is also a test of model fit. The Hosmer and Leemshow statistics indicates a poor fit if the significance value is less than 0.05, which is when the test is significant. Here the model adequately fits the data. Hence, there is no difference between the observed and predicted model. Now, apart from that significance test, we've got here a contingency table as well. Now here we see that the values are almost equal for both the choices. And this shows that the model adequately fits the data. As we can see, there is no difference between the observed and predicted model. They are almost equal. If we look here, they are almost equal. So your data fits your model. Next up is your model summary, as we get in linear regression as well. Here we've got our R-square values. We normally use Nagelkerke R-square, which is a pseudo R-square, not actually an R-square value. So model summary shows the pseudo R-square. Pseudo here means that it is not technically explaining the variation, but they can be used as an approximate variation in the criterion variable. So normally used is a Nagelkerke's R-square. This is an adjusted version of the Cox and Snell R-square, this one here, that adjusts the scale of the statistics to cover the full range between 0 and 1. In this case, 70.7% change in the criterion variable can be accounted to the predictor variables. Next up is your classification table. Now this is particularly important. The classification table provides an indication of how well the model is able to predict the correct category once the predictors are added into the study. Now we can compare this with the classification in block 0 to see whether or not we have got certain improvement when the predictors are added to the model. The model correctly predicts, or the model correctly classified 75.1% of the cases. Actually this is a typing error, 75.7% of the cases. Sometimes it is referred to as percentage accuracy in classification. Now based on your data, this actually tells us how well the model is able to predict the correct category. By the model, we mean our independent variables predicting the dependent variable category. Now in other words, this is the rate of correct classification if we always predict that a respondent would choose private sector bank. So how many times would we be correct? This is our correct percentage. Specifically, it presents information on the degree to which the observed outcomes are predicted by your model. Moving on, the percentage in the first two rows here, this one and this one, it provides information regarding specificity and sensitivity of the model in terms of predicting the group membership on the dependent variable. Now, specificity, also called true negative rate, it refers to the percentage of cases observed to fall in the non-target or reference category, those who will not select the private bank, who were correctly predicted by the model to fall into that group. That is, they were predicted not to select private. So we wanted our respondents, or we wanted to find out those respondents who would prefer private sector bank. So in this case, this percentage is quite low. And in this case, it's just 17.8. So we have correctly predicted that this is the number of people who will not choose the private sector bank. Whereas sensitivity, also called true positive rate, it refers to the percentage of cases observed to fall in the target group, those who will select the private bank, who were correctly predicted. So your correct prediction for private banks falls over 95%. The sensitivity is 96.4% here. It is good enough, very good. Overall, the accuracy of the model is 75.7%. The model exhibits good sensitivity since among those persons who will choose private banks over public banks, 96.4% were correctly predicted. So your correct prediction for those who will choose private sector banks over public sector banks is 96.4%. So you've got good sensitivity in your model. Your classification is appropriate. Moving on, this is what we are interested in. Which of the independent variables have got a significant impact on our choice of bank? So odds ratio, or odds, is the ratio of probability, PA divided by PB. Probability of A, or choice A, divided by probability of choice B. Now this table shows the relationship between the predictors and the outcome. Now these are the predictors here: technology, interest rate, value added service, so on and so forth. Beta is the predicted change in the log odds. So for 1 unit change in the predictor, if there is 1 unit change in here, this is the change in your probability of outcome. The beta coefficient can be negative or positive and have t-value and significance of t-value associated with each, just like we have in our normal regression analysis. Now further explaining the variables in the equation table, odds ratio. What if your odds ratio is 1, exactly 1? So your probability of falling into the target group is equal to the probability of falling into non-target group. However, if odds ratio is greater than 1, now there is a probability of the event occurring, that is you falling or you choosing your private sector bank as preferred bank. Now probability of falling into the target group is greater to the probability of falling into the non-target group. Here the target group is your private sector bank. So there is a high probability of falling into the target group, that is choosing private bank for your services rather than choosing public sector bank. The event is likely to occur. In this case, better technology obviously will lead you to choose private sector bank. Same is the case with this one, same is the case with this one, same is the case with this one. And the rest are less than 1. So they have a low probability of the event occurring. So odds ratio decrease, or odds ratio less than 1. So there is less probability of event occurring, or the probability of event occurring decreases. So the probability of falling into the target group is less to the probability of falling into the non-target group. the event is unlikely to occur based on these variables. Now, we can say that odds of choosing private bank offering value-added services are 1.367 times higher than public sector bank. 1.36 times higher than public sector banks. So those banks who offer value-added services, private sector banks offering value-added services, the odds of people selecting private sector banks over public sector banks increase by 1.367 if they offer value-added services. And this is with the 95% confidence interval of 1.097 to 1.703. There is no zero in between. So this means that this value-added services as a predictor is significant in the probability of the event occurring. Now look at this one here. It is significant because it's less than 0.05, but it is less than 1. So the odds of the event occurring, that is people selecting public sector banks, is less than 1, and the sign is negative as well. So the higher the perceived risk, the probability of event occurring actually decreases. So when the perceived risk is higher, the respondents will not go for private sector banks. Now the important thing about this confidence interval is that it doesn't cross 1 here. It doesn't cross 1, doesn't cross 1, doesn't cross 1. So both values are greater than 1 for this particular predictor, and your odds ratio is also greater than 1. And this is important because values greater than 1 mean that as the predictor or the predictor variables increase, so the odds of, in this case, selecting private bank also increase. Value less than 1 mean that the opposite as the predictor increases. So the odds of selecting private bank decreases, as is the case in this one. And your confidence interval was less than 1 as well. So your perceived risk increases, your odds of selecting the private bank actually decrease. So that's why it's less than 1 and your odds are also less than 1. Now here is a reference that one can use. I hope this video would have helped you understand the concept of binary logistic regression and how to use it in SPSS. Thank you very much.